Example again for calling a method with passing the argument. If you notice, we have a public main right here, and right here inside the main we calling another method, and we call that one display message. Display message right here supposed to passing an argument of type of a string. This is the header of our method, new created method. It passing a value of a string, the variable of type of a string, which we call it the class type of a string or object of the string, and the value of that inside that string object is a Scott. So it passed the value a Scott right here, and then you're going to start the body of the method, and inside of the body of the method you're going to say hello a string str, and str right here is Scott, so you're going to be hello Scott. That's going to be the output. Well, you may asking me why we need a method, why we need more methods separated than our main method. Let's consider in this example, I wrote a tiny example to try to show you. This is a method that is going to compute the raising a number to a power. Always when we try to run compute a method, we're going to say, for example, 2 to the power of 4, and we passing inside a method, that method execute and return the result 2 to the power of 5 is, for example, 32. This process, because we have to call it over and over and over for any let's say computation of a raising a number to a power. So we're going to write a single module, and we call it over and over and over again. So what I mean by the module, I mean a method. We're going to write a method, we call it power, and this code is going to be inside my class program, class main method, and anytime that I want, I call this method from another method. Let's try and run this example. I ran in this method. Let me explain this method to you. This one example, for example, we would like raise to power of 5. Let's look at 2 to the power of 3. This example right here. X is 2, y is 3, and so you're going to come right here and grab the int temp, and base are declared to variable. Then you're going to say for I x is equal to I equal to 1, I less than y, which is 3, loop, take the value of the x, which is 2, raise it to multiply by itself and put it to the base, multiply by itself and put it to the base. So you're going to 1 time, 2 time, 3 time, raise x, multiply x by itself, so you're going to get 8. And when you're going to get 8, you're going to return the value to the caller program. Let's test this example. The program is in this format. We have public static, string, power, int, and y. Int variable as input argument and y as input argument. So we're passing the value x and y, which they are type of the int. And as I explained it before, we're computing this one and multiplying whatever is the value a of the x y time to itself, and then we're going to return the result. If you notice, I put right here if a statement. You know, any number raised to the power of 0 is equal to 0. Any number raised to the power of the 0 is equal to 0. I take my word back. Any number raised to the power of the 0, in case if the y is 0, any number raised to the power of 0 is equal to 1, not 0, is equal to 1. So in case if the value of the y is 0, consider to return 1 for that program. So this is normally a power example that I wrote it right here. Now somehow I have to read x and y inside my main method right here. This is an example of the main method. I'm going to say enter the value of the x, converted to the integer, put him in the x, enter the value of the y, converted to integer, put him in the y. Right here I have to call my method power, so I can say right here So right here I want call my let's say undo this one, so one more time undo, and right here I like to do a system output and call the power function, pass x and y to that one, this x and y, and then you're going to compute the result, and as a result of that one return me the value. So let's put it this way again. Let me put this power in the same indentation as the top line. So here's my power function, and here is the way I call that one. Let's go ahead, run this program and see the result. I'm going to run it, putting 4, let's say a number that we can, 2 to the power of 5, and the result is what? The result should be 32. I didn't compile the program anyway. 2 to the power of 5, the result 2 to the power 5 is equal 32. That's what is going to return right here. You're going to return this statement right here. So in this program, as you're going to see, all we have to do, we have to call the statement system and calling my function power. So right here, as before, I have a header of my Java class passing argument with the main method. Then inside that one I'm going reading to value x and y. Then right here I'm going calling the power function, which we define it right here, and it's going to pass a value x and y to this one, and it's going to return the value of the other one, 2 to the power 5, or any number to any power. Let's consider I want to run this example, 7 to power of 8, and it's going to be the 7 to the power of 8. It's going to return the result. Now I try to explain you why we need the method, why we need to have to break down a program to many tiny methods that we can call them based on the requirement of the or application. Look at right here. I need this power function many times. When you're using the Excel, application, you're going to use power many times, not only for two number, but for many different form of number. So you have to have a tiny method that it compute the power of two number and return the result. So for this purpose, if I have a big main method, I'm going to break it down to a small tiny method, small method, and I call them each method based on the requirement of my application. So I may use this method, as I explained it one more time, many times, whatever in my program main method that I need it. Here is another view of the program again. So if I have a power 2 to the 3, this we call it actual argument, we call it to formal argument, and right here this 2 go right here replace with this x, this 3 replace it with this y, and the x is going to be right here. The x and y goes inside our for statement loop, and for statement loop based in description that I explained to you, you're going to compute the result and return the result based on this example, return the string. We can change it that you're going to return the integer or return double. Both of them is possible. Here is again the same example. You're going to see that one that we're using the API Java X swing option pan, and in that one also we gonna change the program slightly, that this time instead of the returning a string, you're going to return the integer function. And what I'm going to do, I'm going to ask compute the power of a number. When you finish and exiting from your for loop statement, put him in the base and return the base, and return the type is what? Integer. So whatever I have right here, this should matching this return statement. So this is if the value of this one is integer, this one the type should be integer. So public static power in power, and this is the value of integer data type, y integer data type, so this x and y should be integer. By the way, it's not necessary this one should be the actual, the difference between the actual argument and formal argument, they should not have a same name. It doesn't matter, you can using the same x that you're using right here, or and using the same y that you're using here right here, or you may putting right here, for example, 3 7, and right here you have x and y. So it really, they are not very much dependent, only the type dependency is important, that this is int and this one also is int. Okay, and by the way, see, there is another example on the page 95 of your book. So this one returning the integer data type for us. I want to mention something that we spoke in chapter 3, and we're gonna make it, I think, a previous chapter, let's put it this way. See, right here is the purpose of the for statement. In this example we use the for statement because I know what is my x, what is my I, and what is my I and what is my y. So I know that the best scenario that I use the for statement instead of the while statement or loop statement. Now let's look at this slide. This slide, the only thing that I did different is that I put a do loop right here and asking process this one for n time, and I'm going to say while y not equal to 0 or x not equal to 0, compute a number for me. So you can run this program for many times and raise the number to a power, and it's going to return your value. But as soon you put the y is equal y is 0 or x0, you're going to terminate the program and stop it. So y0 x0, then you're going to stop it. But as long as the y and x they are greater than 0, you're going to compute and return you the result. As you see in this program, this is the purpose of the do loop. Do loop I would like to use it in the power function, for example, without checking any condition, go inside the loop and compute the result. If I don't want it, stop it. If I want, continue that one.